Hello and welcome to this video. In this video, we will solve the next 10 problems of arithmetic progression which we are dealing with, and there will be a lot more problems to solve. These problems are also somewhat easy. So let's get started. Now the 11th problem is that show that the sequence 9, 12, 15, 18 and so on is an AP, and we have to find the 16th term and the general term. So, as always, you should pause the video here and not look at the solution. So now, as you see that the common difference will be 3 because 12 minus 9 is 3, 15 minus 12 is also 3, and 18 minus 15 is also 3. So since it's a constant, the given sequence is an AP. So first term is 9 because that's what the AP starts with, and common difference we have found to be 3. So the 16th term would be a plus 16 minus 1 into d, that is 9 plus 15 into 3. 15 into 3 is 45, so 45 plus 9 will be 54. That is what is our 16th term. The general term will be a plus n minus 1 into d, that is 9 into n minus 1 into 9 plus n minus 1 into 2d. N minus 1 into 2, sorry, that should be 3. N minus 1 into 3. So n minus 1 into 3 would be 3n minus 3, and 3n minus 3 plus 9 would become 3n plus 6. I'll correct that mistake before uploading it to GitHub. Now let's see the problem number 12. We have a sequence of log A, log AB, log AB square, log AB cube, and we have to show that it is an AP and we have to find its nth term. So if we subtract the consecutive terms, then second term minus first term, that is log AB minus log A, will be equal to log B. You have to know the logarithmic series fundamentals before you can understand this. So I hope that from your previous class you understand how logarithm works. So how it works is log x minus log y is equal to log x by y. So we have got log AB minus log A is equal to log AB by A. A gets cancelled and that will be log B. That also stands true for log AB square minus log AB and log AB cube minus log AB square, and our common difference becomes log B. And it is a constant, therefore the given sequence is an AP. Now the general term is A plus n minus 1 into D. Sorry, again that's a mistake of typing. A plus n minus 1 into D. So that becomes log A plus n minus 1 into log B, which is equal to log AB to the power n minus 1. Now we have to find the sum of n terms of the sequence, where nth term is given as 5 minus 6n. So let's see how it works out. Since nth term is 5 plus 6n, 5 minus 6n as given here, we have tn plus 1 minus tn is equal to 5 minus 6 into n plus 1 minus 5 plus 6n is equal to 6 for all n belonging to set of natural numbers, which is a constant. So our given sequence is an AP. By putting n is equal to 1, we have got t1 is equal to 5 into 6 into 5 minus 6 into 1, which is minus 1. So the sum will be n by 2 into t1 plus tn, which is the formula which we have derived in our second video when we dealt with the theory. So by substituting the values for t1 and tn, we arrive at the solution as n by 2 into minus 1 plus 5 minus 6n. 5 minus 1 will be 4, so 4 minus 6n. When you divide that by 2, you get 2 minus 3n. So the final answer is n into 2 minus 3n. We have another AP 3711 to 407, and we have to determine how many terms are there. The first term is A, and common difference we derive to be 4. The formula for general term leads us to the equation 407 equals to 3 into n minus 1 into 4. So 3 plus n minus 1 into 4 will become 3 plus 4n minus 4, which is equal to 4n minus 1. So 1 gets added to 407. equals to 4n. So 408 equals to 4n, so n is equal to 102. That's what the general term is. And so now n is 102, so we have 102 terms in the series. Now we have another one, that is if a, b, c, d, e are in AP, find the value of a into a minus 4b plus 6c minus 4d plus e. So for this, we assume that P is the first term and Q is common difference. Then we write the values of each term. So P plus A, P becomes equals to A, P plus Q equals to B, P plus 2Q equals to C, P plus 3Q equals to D, P plus 4Q equals to E. So now if you see this, then A plus E is equal to 2P plus 4Q, which is equals to 2C, because C is P plus 2Q. So 2C will be 2P plus 4Q. And similarly, B plus D will be equal to 2C. Now we combine the terms of B and D and A and E. So by substitution, we get the result as 0. So next problem is that in a certain AP, 5 times the fifth term is equal to 8 times the eighth term, then we have to prove that 13th term is 0. So we have that fifth, we assume that A is the first term and D is the common difference. Then fifth term is A plus 4D and eighth term is A plus 7D. We multiply them with 5 and 8 respectively, which gives us 5A plus 20D equals to 8A plus 56D. And when we bring that to right side, it becomes 3A minus 36D, and we take out common 3, then it becomes A plus 12D equals to 0. That is 13th term is 0. So that's how we arrive at the answer. Next we have a series, and we have to find the smallest numerically positive number. So we get the first term as 25 and D as minus 9 by 4. Substituting for nth term, we arrive at 109 by 4 minus 9 by 4n. So this will be negative if Tn is less than 0, which gives us a result of n greater than 12 and 1 by 9. So the 12th term will be smallest positive number, because n is, if n becomes greater than 12, then Tn will become negative. So T12 will be the smallest positive number. Substituting for n is equal to 12, we arrive at the value of 1 by 4. Now, another question is that a person was appointed in the pay scale of 700, 4 to 40 to 1500. Find in how many years he will reach the maximum scale. So in this case, his initial payment will be 700, and every year it will grow by 40, and eventually he will reach to 1500. We have to determine how many years it will take for him to reach that number. So here Tn is 1500, A is 700, and D is 40. Substituting that, we arrive at n is equal to 21st. So he will reach there in 20 years, because after 20 years it will be A plus 20D is equal to 21st term, which is 1500. Now we have an AP whose 7th term is 34 and 13th term is 64. We have to find the AP. So we substitute the values of 7th and 13th term to get A plus 6D equals to 34 and A plus 12D is equal to 64. We subtract T13 minus T7 gives us 6D equal to 30, which implies that D is 5, because 6 5 are 30. We substitute this value of D in 47, we get A plus 6 into 5, that is 30. A plus 30 equal to 34. So A equal to 34 minus 30, that is 4, and thus our AP is 4 plus 4 comma 4 plus 5, that is 9, comma 4 plus 5 into 2, that is 14, and 19. Now we move on to the last question. The question is 55 a term of the sequence 1357? If yes, find which term it is. So here also we have A equals to 1 and D turns out to be 2. We assume that 55 is the nth term of the series, so we get the formula 55 is equal to 1 plus n minus 1 into 2, arriving at n is equal to 28. So since n is an integer, that is no fractions involved, we can conclude that 55 is a member of AP and it is 28th term of the AP. So if you have liked this video and found it informative and helpful, then please like the video and subscribe to the channel. And please let me know in comments that if you find these videos useful, so that I get the motivation to make more such videos in a rapid way, because it motivates me if you like my videos. Thanks a lot for watching. Happy solving the problems.